Hello everyone. This is about identity and access management tutorial. So it starts from uh, the basics. Uh, so uh, this course will be helpful for everyone who is new to identity and access management, and those who are experienced in IAM domain as well. So okay, let me tell about myself. My name is George Thomas. I have several years of IT experience, and in IAM domain, I have 13 plus years of experience in enhancing an IAM product. So let's look at the agenda of today's section. So basically, I'll start from the basics, then slowly progress further, and finally, I'll give a brief on Keycloak. So it is not necessary that after this you should be using Keycloak. You can use any of the identity and access management tool. So the theory is being covered here. And as an example, I'll show something on Keycloak at the end. So here we see the house of we see, sorry for that. Here we see the picture of a house. So how can we enter this house? So we should be having this house is of course is locked, so we should have the right key for that. So if we want to enter this house, we should be having the right key because the door is closed. So if I think about IAM systems also, it is something similar. So you want to access, suppose, abcbank.com website, and you want to see confidential data in that, then you should authenticate yourself. You should have the key for that to identify that you are somebody as an account in that bank, and my credentials are this. So it is as good as saying going to a house, putting the right key and opening up. So when you do that in the website world, okay, when you go at the browser and you type abcbank.com, you get a page, okay, and but you if you want to see confidential data in that, you should have the right credentials. So IAM is about identity and access management. You have to say, you have to prove your identity. And once you prove that identity, and based on your roles, you will be granted access to resources. So let's look at this diagram. And in this, so over to the left, you can see what you can see is the browser. So you can see is the browser over to the left, and over to the right is the web server. So when you access a bank or whatever be any URL in a browser, so then it's back to the server. So assume this is what you see on the right is a web server. Okay, your request is flowing from browser to the web server, and there is a plugin like IAM in the web server which will intercept your request. So before the web server do any processing, it will first intercept your request, and it will decide what to do further on that request, and then only give control back to your web server. Finally, a response will be sent back to the browser. Okay, we may observe that. So probably I go to any website. Uh, I may have to authenticate only once normally. It is not quite common. There are different cases out there. But in a normal authentication system, if I visit a website, I have to give the credentials only once, but HTTP requests are stateless. So when you go to browser and type your URL in the browser, and request is initiated, and you get a response back from the web server sitting somewhere else. So again, you click on something, another request is being initiated from your web server, and it is going to the it is initiated from your browser, and it is going to the web server, and a response is got from web server. So these two requests are stateless. The one sitting web server at the backend cannot know it is being the same user is trying is coming back again. He initially came. Okay, I gave this response, and now he is coming with a different URL. He click their link or something like that. But there is no way for server to know by default the same request is being originated. The same person is being sending the request. So that is called HTTP as stateless. So in order to build stateful nature, so why it's important, stateful nature is important. So I can there give my password, give my credentials, I log in, I got a resource, I got a page, welcome, welcome and all, I got a page. And finally, if I click on something again, I get a login page. That means it's not, again, I have to prove my identity. It is not good, right? So that is why a section is being created normally in IAM systems. A section is being created. So when you authenticate yourself and a section is created at the web server, and that section you can call it a section cookie. Okay, so, and a response is coming from the web server. So with the response, there is a section cookie is also being retained from the web server. So that gets stored in your browser. So when your browser section is active, whatever requests you make to the same website, same domain, whatever requests you make, this section cookie will accompany the request. So even if I click on 5 times on a link in the same website, every time this section cookie will go. That section cookie you got when you authenticated at the web server. So the web server as a way now to identify you. Okay, he logged in before because of section cookie. It has stored the section cookie there. Because of that, he can know that it is the same user is coming back again. So against the section cookie, there will be some information will be stored, and it will validate whether you are, so it's a genuine or not. It will validate like that. So this is one way of mitigating the stateless nature of HTTP requests. And another common is nowadays is the token. So that is also JWT token and all. It's being used for mitigating the stateless nature of HTTP requests. So okay, I had some problem in browsing to the next slide. Okay, so these are the 4 A's in IAM. So why it's being called as 4 A's? Everything start with a capital A. Authentication. What is authentication? You say you are, so I am George. I say myself is George. I have this password. Okay, I'll authenticate with the system. And authorization. Suppose you work in a company, you are a programmer there. Okay, you have got a role now. You are a programmer in a certain company. So that is called authorization. There are different techniques are being used, different ways. There are role-based and attribute-based access control in authorization. We'll come to that later. And another is accounting. So that is for auditing purpose for legal requirements. And the next is administration. So when you work on IAM systems, if you are IAM administrator and all, so normally you have to manage the users in a company. So somebody comes, joins your firm, gets promoted in your firm. is getting a new role, or he is leaving the organization. So all these administration tasks are being are also being part of your part of IAM. So now we will look on single sign-on. So let's look at the case as before single sign-on. Okay. So normally, when I started working and all, I had to access different applications. Everything has got a different password for me, username and password. It is stored separately, but they so if I can log in everywhere using a same password. So our company has got different application. One for entering timesheets, one for the payroll system. So likewise, there are different applications are there. So I have to remember a lot of passwords there. And the company employees are being stored in probably in Active Directory. Employees informations are stored in Active Directory. So all these applications has to read from Active Directory and get the credentials and validate the credentials and all. It has to individually do it. So that means I have to uh, um, okay, so I may not be exactly correct on that. If it is if it is having same database everywhere, you will be having same password. Only thing is that you should have the interface to read the password from a database for each of your application. Okay, you should have the interface. So think about a system with a different database. Okay, so one application is having one database and another is having another database. So you'll have different passwords in at the two places. So so let's think about single sign-on. So single sign-on is something uh, sign on means so suppose in our company what we use is we have our customer our employee data stored in Active Directory. Sorry, probably in Microsoft Azure Active Directory. Uh, and now it is being called Entra ID. So user data is being stored there. So the timesheet application. So let's call it Oracle Fusion, or what will be. So let's call it. It has got features to enter timesheets and a lot of other things. It can be done in Oracle Fusion. So that is one of the application in your company. Assume I will call this Oracle Fusion, and there is another payroll application also is there. So all these applications will reach out to Microsoft Azure Active Directory because my credentials are being stored there. Okay, all these applications will can reach out to Microsoft Active Directory because the credentials are being stored there, and and it can uh, and it can establish a trust between the Microsoft Active Directory and your Oracle Fusion or payroll accounts and all. So this is something called, I'll explain it more detail when I go to the coming slides. This is something called single sign-on. Okay. So you have the Oracle Fusion, your HR system application. Okay. So when you want to work on it, do a single sign-on, and that will take you to Microsoft Azure Active Directory, and where you enter your credentials for Microsoft Azure Active Directory, and it will say it recognizes you. It will return back the request, and uh, and it will say you are a legitimate user. So Oracle Fusion is happy now because Microsoft, I have a trust in Microsoft Active Directory, and it has said that this user is legitimate. So it will grant the permission. So it is building up a trust between Oracle Fusion and Microsoft Azure Active Directory. Similar way, you can set up another application is coming to your company. So that is payroll. So the payroll application also can establish a trust between Microsoft Active Directory. What is the advantage? Your user data are already part of Microsoft Active Directory. Your user data are already part of Microsoft Active Directory, which your company HR is maintaining. Okay. So if somebody leaves, it is being removed from there. If somebody joins, it is added there. So everyone can log in. So say with the same password, because every time authentication is happening at the IDP, identity provider. So here I consider the example Microsoft Active Directory, Microsoft Azure Active Directory, and so that is my identity provider. So there are two parts to this in SSO. One is service provider, and another is identity provider. Here our service provider is Oracle Fusion, which is catering my HR system, catering my timesheets and performance management software and all. It is being done. It is doing that kind of work. So I need to authenticate there. Then the service provider will contact identity provider, which is Azure Active Directory in my example, which I have illustrated. Okay, so there is a trust between service provider and identity provider. Likewise, there can be any number of service provider in your organization. Any service provider means one kind of application which relies on an identity provider for 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 uh, authenticating, okay, and establishing the identity of a user. So the advantage is that any number of applications can be there. So we discussed about section cookie a little while ago. So what happens in single sign-on is that so the Oracle Fusion, the service provider, when it, say it has logged the one who is clicking on single sign-on at service provider, he has authenticated with the Microsoft Azure Active Directory. Assume he got a section cookie back. So that was the initial what we are saying about for maintaining the stateless nature of HTTP requests, session cookies are being created. So he got a section cookie back because now my Azure Active Directory has to identify this user. So he got a section cookie back. This same section cookie will go with the payroll application also, because when you click single sign-on on payroll application also, the same section cookie will uh, go to the Azure Active Directory, because it is being issued for a certain domain. So assume the domain is microsoftonline.com. So the redirection of URLs are happening and all. Okay, when you click on single sign-on link of your payroll portal, okay, so that is gone to Microsoft.com. So that time your section cookie is being gone. That was created initially when you assess the timesheet application, Oracle Fusion. But now with the payroll also, the same cookie is being going because your browser is having that cookie. Okay, so this section cookie is from this user. He's already authenticated. He's a valid user, so he don't have to repeat the login there. Sometimes, based on configuration, it may have to be repeated. Okay, but the idea is that with the same credentials, I can log into any of these service. I can access this any of the service provider with the same credentials of identity provider. I can access any of the service provider, which has formed a federated trust between each other. So how does this all work actually? Okay, so if you think about this, how does all this work? I took an example of Microsoft Azure Active Directory Entra ID, which is recently it is being called. And I took an example, so that is being considered as identity provider. So the service provider I mentioned as Oracle Fusion is one, and another is a payroll application. So all these applications are coming from different companies. Then how does it trust each other? How does it talk each other? So there has to be standards are there. Okay, for that actually there has to be standards uh, for uh, for communication between two parties. Okay, and as you see in the screen, there are different standards are there: SAML2, OAuth2, OpenID Connect. Okay, so you may think why all these different protocols are there. SAML2 came in 2005. So that is the first standard for SSO. So that is based on XML format. That is based on XML format means the ADP and SP communicate each other. Okay, they have to communicate. Okay, I'll say this user is known to me. Okay, I'll send a request to IDP. Service provider will send a request to identity provider. So, okay, that please authenticate somebody. Okay, somebody click a SSO link. Please validate him. Okay, so likewise, there will be a SAML request will be sent to from SP to IDP. SAML request. That SAML request is in XML format. Okay, this is as per SAML standards. Okay, there is a standard body which has created SAML standards OSS. So it is based on that standard, and that is why these two different systems from different companies can identify the XML data and arrive at can understand each other. I send an envelope to them, and they opening the envelope, they can understand what is inside, what is that requirement. So it is able to understand actually. So that is in XML format, and so in the production systems and all. So these communications between the SP to identity provider go in encrypted format only. Encrypted means it cannot be readable during transmission. Okay, and this standard was there, but still O2 and OpenID came. O2 came in 2012, which O2 stands for Open Authorization. So when SAML was there, the mobile era has not that begun. So it was in premature state probably. So then O2 came. So that is based on JSON format. So here The SAM will exchange the data, communicate with in XML format between SP and IDP. But O2 and OpenID Connect will communicate with a JSON payload. So why we have different standards when SAML was there, why again to OpenID Connect is there? Because it caters to different needs. So for mobile applications, probably for some of the things I have to use OpenID Connect. I cannot use SAML. It's mainly for browser-based applications. So for mobile applications and all, and not only mobile browser applications also, I can use OpenID Connect. So OpenID Connect is the authentication plus O2 is OpenID Connect. So it is on top of O2 OpenID Connect. So it brings the authentication part to the authorization specification, that is O2, that is OpenID Connect. So it is built on top of O2, which brings the authentication part. Identity layer on top of O2, and it brings authentication. That is called OpenID Connect, and it is came in 2014. So although we have different protocols are there still in industry, SAML is also used widely. OpenID Connect is used. So for some of the things, OpenID Connect, like mobile and all applications and all, OpenID Connect is the right choice. For some of the things, both can be used, SAML and OpenID Connect. So based on a case to case, when we configure different SPs and IDPs, we have to arrive at a situation which protocol you have to use. So these are all built on standards. So all the companies who build the IAM systems follow these standards. So that is why an Okta system can communicate with Keycloak, or Okta can communicate with the Azure Active Directory, because they all built on the common standards. Okay. So although SAML came first we will look on OpenID Connect actually. There are different grant types are there. So what is a grant type? So I said actually in the case of OpenID Connect, what I get back is a JSON payload. What the communication is JSON payload, and what I get back is a JSON web token actually, normally in OpenID Connect. JSON payload, which contains a JWT token as well. So there are different code flows are there. That is mainly for CAN types are there. That is mainly to cater to different requirements. So there is authorization code flow is there. Okay, that is meant for server-side application like Java, Spring Boot, that kind of applications, Spring Boot framework. Okay, so which can do some logic in the backend. So authorization code flow can be there. Implicit flow, client-side applications, it's more suitable. So if you think about client-side application, that is the one which is running in browser. So where you cannot maintain some confidential data. So if it is something which gets executed in the backend, you can have confidential information there. But if it is something which is exposed to the front end browser, you cannot keep the secrets. So for such, implicit flow was there, still there. And as an improvement, there is authorization PKC, proof key code exchange, which can be used in browser flow, the browser applications also. For example, your React.js application, I can use authorization code PKC, Pixie, I hope it's a short form. So we will come to these protocols in the coming slides. So let's look at the first grant type. So I said why there are different grant types. I'm not covering all the grant types. I just took 2 or 3 from each of the category. So right now we are discussing OpenID Connect. I took 3 only, just to give an idea why there are different grant types are there. There are more out there. Similarly, for SAML, I will take 1 or 2 grant flows and I'll explain. Okay. So basically, authorization code flow. So this is for server-side applications usually being so when we also why what we are doing with OpenID Connect, we want to have SSO login and all being configured. Okay. And for that, the standards I am following is OpenID Connect, and in that I'm going for grant type authorization code flow. So when we discuss about OpenID, it's discussed about single sign-on. So we said that there are 2 parties there. Service provider, I said the timesheet application or the HR system, the Oracle Fusion I mentioned. And there is Azure Active Directory, the identity provider I mentioned. So similar, the term used in OpenID Connect is something different. It is not normally said as service provider. Service provider is known as a laying party in OpenID Connect terms. And the provider is known as a OpenID Connect provider. So in SAML terms, it is being said as SP and IDP, service provider and identity provider. But when you come to OpenID Connect, it is being called laying party and OpenID Connect provider. So I go to my say payroll application. So I get in the browser, I go to the payroll application. So the IAM admin has configured in such a way that I have to click an SSO link there in the application to get authenticated. So that is happening at the that is happening here. So I click the link in the browser. The user has clicked the link, login link. Okay. So what is the laying party? So think about it's a React.js application that is having laying party inbuilt in that. Think about it like that. So when you click on SSO login, your laying party will communicate with the Microsoft Azure Active Directory if it is configured that way. Identity provider, it will communicate with that, and it will send a authorization code request. So I'm using grant type as authorization code flow. A request is being sent to OpenID Connect provider, which is in our example, we are saying it is Microsoft Azure Active Directory. So Azure Active Directory does not understand this user, even though it does not understand who is, there is no session cookie and all coming with a request. So it does not understand. It's the first time it is a request is being come. So what it does is that it will challenge the user to enter the credentials. Authentication request is being come. So he complete the login and consent. There's a way to, there's another window will come for consent. So that's back to OpenID Connect provided. So the OpenID Connect provider finds, so now it knows that the user is legitimate because he is able to authenticate correctly, but still the lane party has to prove that it is the one registered with the OpenID Connect provider. So before this, when configuring IAM systems, there is a client registration process is there. So when you register the process, register the client. So assume when you register that, so you have to say which grant flow I'm using. So I said it's authorization code flow, and then you will get a client secret and all. So that you have to submit. So that's a requirement of this authorization code flow. So is that because I cannot maintain the secrecy of client secret uh, in the in the browser applications. Okay, so here you assume this lane party. So in authorization code flow, maybe a Spring Boot application, not a React.js application. It may be a Spring Boot application. Okay, where the where I can maintain some secret in the backend Azure Active Directory. Okay, so so in the first flow, it has authenticated, proved the identity, and as a response, it has got authorization code back. So think this is so I divert from the analogy of React.js and Azure Active Directory. Instead of that, I'll say Oracle, Spring Boot, and Azure Active Directory. Okay, because it's authorization code flow. So here, so in the first flow, I got an authorization code back. So then there is a back channel request is originating from your lane party, Spring Boot application to Microsoft Azure Active Directory. Back channel request, what is a back channel request? Without the involvement of browser. So directly your Spring Boot application, just assume it's a Spring Boot application or Oracle Fusion or what would be, it is which is running in the backend, is directly making a call to with the authorization code and the client secret, which it has got while registering initially. So before establishing, so before configuring the IAM system, so at the time of configuring IAM system, I got a client secret. That client's pay, it can validate the client secret. Oh, okay, it's line party is proved is the identity. So now I can give us a token. So it will give us a token, ability token. So it gives a JSON payload, and in the JSON payload, actually, as a response back to laying party. And in the JSON payload, there is ID token, access token, and all. Access token is normally not necessary to be a JWT token. We'll come on JWT token later. What is that? ID token is a JWT token which has claims for the user. Okay, so the user authenticated is something called Alex. So that is the user authenticated. So it is saying in the claims it is having that info. He authenticated at this time. So that is also this time. So that is also part of claim. So that kind of claims are being listed in ID token. So this access token is a confidential information. Once the laying party has the access token, if there is a resource server is there, okay, it can communicate with that resource server by supplying this access token, and it can make communication between this is a protected area resource server. Okay, and that protected area, it can access through the access token. Okay, it's a confidential data access token. So that also is a back channel request only. So it is not through browser. So you make a API call, you get the response. So you can communicate with the resource server. So that is about authorization code flow. So we discussed there are different grant flows are there, and I mentioned there is one grant flow called implicit flow also there, which is for uh, client-side applications. So the difference in that is that it cannot maintain client secret. So when one lane party and OpenID Connect reach an agreement, it will say that when the client is being registered, it will say I need implicit flow. So if that is the case, client secret is not generated because it's not, even though if it is there, it cannot maintain the secrecy in the browser. So there is no usage of that. So this step is not there. This flow is not there in the case of implicit flow. Instead of that, in the first flow itself, you will get the access token back. As a result, it's not that secure. Okay. So people thought of improvement to this, and Then came with the authorization code PKC. I have some problem in getting to the slides. So this is called authorization code PKC. PKC also, I think it's being called. So this is suitable for client-side applications also. Why? There is no secret here. Then how it works? Instead of secret, there is a code challenge is there here. So it just gets generated every time for every request flow. I think it gets generated fresh. So how does it work? So here again, we consider the client. Uh, so take your example as a RIHS application here and authorizations, and this is your assured active directory, assume it like that. Okay, so this is your IDP in simultaneous, this is your SP in simultaneous, and your OpenID Connect, this is your lane party, and this is your OpenID Connect provider. So here also there are two flows are there. In the first flow, I get authorization code flow, and in the second flow, I get access token, and of course, ID token also will be there. So how it is different from the flow which we have discussed in the previous step? So basically, it differs in that a code challenge is being created. So and the code challenge is hashed with say with a method. So that method is say this method is sharp256. Assume it is sharp256. So you should be knowing the difference between hashing and encryption. Hashing is something we use an algorithm. So I have got a same password or something like that. It is there. That string I can hash with an algorithm sharp256. So every time I do this hashing, I get something as output. But from the output, I cannot get back the original value. So that is called hashing. It's not reversible. I cannot bring back the original value. But every time I use the string, say password, and use the same hashing method, I get the same output, but I cannot bring back it. But in case of encryption, normally you do with symmetric or asymmetric keys. So if you encrypt with a key, if you have got a matching key in the case of asymmetric keys, so you can decrypt the payload. You can get back the original data. So that is the difference between hashing and encryption. Okay, that you should be understanding. So here what we are saying is that a code challenge, a string is being generated. Okay, that string is being hashed with a say with the SHA-256 algorithm. So when I make an authorization, okay, so you can assume this is an authentication request. Okay, so you make an authentication request. So when you make that authentication request, this hashed value of code challenge and the method used for hashing is being sent to the authorization endpoint. So in case of OpenID Connect and all, what is they are RESTful endpoints. Okay, these are being exposed as REST endpoints. So token endpoint is a REST endpoint, authorization endpoint is a REST endpoint. So so to that endpoint, the code hashed value of code challenge and the hash method also being supplied. So as a reply, you get the authorization code back. So once you have the authorization code back, you will again communicate with the token endpoint. So this time, this is not something, okay, this time what happens is that I'm not sending the hashed value, I'm sending the code challenge itself. Although it's happening in the browser, because it's gets generated for every request, even though it loses the confidentiality, it's okay because it's used only one time. So the code verifier, the code challenge is being sent in the token flow. So what does this token endpoint do is that it already knows from the first flow that the method used in hashing. So the code verifier it gets in second endpoint. So it will do from the backend, from the IDP side, it will do the hashing. So initially it did here from the SP side it did, but now from the IDP side, it will do the hashing of the code challenge and it will compare with the previous. If it is same, okay, these two requests are originating from same party. So it will grant the assist token. So that is about authorization code flow. There is no problem in exposing this code challenge because it gets generated for each request as far as I know. We have a difficult time. Okay. 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 So this is the response I get from a sample response I get from token endpoint. So as I said, this is a JSON payload. So if you observe, it has got access token, which not necessarily be a JWT token. JWT token means JSON web token. We'll come to that. And it expires in this much of, I think this is in seconds, probably. I'm not sure on that. Okay. And the scope, okay, and the ID token, which is having the claims and all, okay, which is a JWT token. It is being part of the token endpoint response. So this access token I said can be used for resource endpoint connection. We can connect with the resource endpoint API to make API calls and all. We can make once you have the access token, which is a secure data. So this is JWT token syntax. It has got two dots. It has got a header and it has got a payload and got signature. So three parts are there. So if there is a online debugger is there, jwt.io. So if you expose your JWT token there, it's a risk, but if it's not confidential in nature, you can expose and see the content. So it has got three parts. One shows the algorithm, one is the payloads and all, claims, username, and claims and all. Okay. And one is the signature part. Okay, so red color here. And so the colors it's being on, you can see a dot. Okay, separating this. So, so how does the signature is being formed? Signature is a it is so first it will take so how does it generate the signature? Digital signature, it is being put here. So first it will take this header, base64 encoding is being done, and put a dot in between, and the payload it takes. Again, base64 URL encode is being done, and the hash value of that is being done, which is not reversible. Campaigned value is taken, and a hash is being performed with a private key. But based on algorithm. So if it is using that kind of algorithm, uses a private key. So this is being done by the identity provider. So as a service provider, I have to validate this JSON web token, ID token. I have to validate. So I have to be sure that it is coming from identity provider only, and whatever be the data I'm getting, whatever be the payload, and I'm getting is not manipulated in the transmission from IDP to SP. So that is done by SP playing party. So what it does is it verifies the digital signature. So again, it will do is that it will do the same calculation as being done for done by the identity provider. So it has got the header, same way it will do. And it will, sorry. Uh, s- so what it will do is that, so you have a signed value using private key. Okay, so using public key, first you have to decrypt that payload. Okay, so uh, sign means you encrypt that. Okay, and you have to decrypt with the matching public key. So the SP side is having a public key, and the IDP has encrypted the hashed payload using public key. Sorry, private key. So SP is having a public key. It's not. It can be accessed from a URL, well-known URL. So it has got the public key and it decrypts the data. And once it is being decrypted, it gets the hash value. So once it has a hash value, it will again do the hash of this and compare the match between two. So if it is same, it can be thorough that the data is not manipulated. So that kind of checking, digital signature verification should be performed by the service provider to prove the authenticity of the request. Yep. Okay, next comes to the SAML binding. Um, So far, we had discussed about OpenID Connect. So when we started the SSO, I mentioned there are different protocols are there. SAML came in, SAML 2 came in 2005. OpenID Connect came in 2014. So OpenID Connect uses JSON payload. SAML uses XML payload. So it has got also similar to grant types. It has got different bindings. So, so as I said, instead of relying party and OpenID Connect provider, here it is SP and IDP, service provider and identity provider. So similar to grant types, here there are different bindings are there. So that also one has got a additional advantage on another. Okay. So that is where different grant types has come. So let's look at them. Okay. So before we go to the post binding, let me so just look at this diagram. Okay, let's look at this diagram. So this is your service provider. So your payroll application or what will be sp.example.com. And identity provider, your Azure Active Directory, idp.example.org. So in your case, if it is Azure Active Directory, it may be Microsoft Online or something like that. Okay. So these two parties are coming. Okay. And your browser is here. So first what happens, I got an SSO link in the browser. When I access the website, I just click the SSO link. Okay. So that's happening here. That request is being happening here. So then a redirection to IDP is being done. And there is a single sign-on service. So these are not clearly REST endpoints. Okay. Okay. So there will be a sublet or what would be, so single sign-on URL will be there. You have a servlet request. What happens, you have a single sign-on URL will be there configured. So likewise, when you said about OpenID Connect, we said the client will register. Same way here in case of SAML, there's here also some registration configuration is needed at the initial time. So I'll say my SS URL is this, and I will likewise there should be some initial configuration is required. So this party knows this this value, this URL and all, so it communicates there. Okay, and then challenge for credentials is come. Then user completes the login, and I said there are different bindings are there. In case of redirect binding, so I just missed on telling about this. When it is going for redirection, a SAML authentication request is being sent. That's in XML format. Okay, authentication request is being sent from here to here, and now it has proved identity. The user has proved identity to at IDP, and now it is coming with a response, an assertion. Okay, the IDP is saying this user is valid because he proved the identity. Okay, now it is giving an assertion. Initially, it was an authentication request came as a response. It's giving an assertion. So how does the assertion comes? That is controlled by bindings. So it can be the assertion can be a part of query string. So then it is a redirect binding. Okay. So you know the query string which comes after question mark. Okay, SAML assertion can come there. So that will be a big value, but it's an encrypted form. So that will be redirect binding. But in the case of post binding, the assertion comes in the HTML form and it gets auto submitted to the SP by a JavaScript code or something like that, which is running in the browser. It's being a post request is being made and it reaches the assertion consumer service. This is another URL running in this. Okay, so that reaches here. So once it has this, now it is okay because it got confirmation. It will validate, of course, the assertion. Okay. So these assertions and all, it's not sent in plain text. Although I said it's an XML format exchange is happening. So all are encrypted and sometimes signed also. So here there is a private key will be there. Similar public key should be here for decrypting and all. So uh, that kind of action will happen. Okay. So once it validates the assertion, once it has the assertion, it will grant the permission to the user for the resource it wants on service provider. So that is about post binding. Now we'll come to the other one. So this is artifact binding. So there is some difference. So this is also similar only to post binding, but instead of authentication request is being done. So after authenticating, instead of assertion, I get an redirect with the SAML artifact is happening. So so that is happening in the case of artifact binding. And that reaches here. Once the SP assertion consumer service gets that SAML artifact, it will make a back channel request. You already know what is back channel. Without the involvement of browser, SP and IDP will communicate. So I got this artifact. So it will send a request. It is a SOAP request because in the case of XML and all, SOAP request is being carried out. Of course, it's all time before rest. Okay, so request is being carried out. Of course, you can have anyway. SAML standard came in 2005. So SOAP request is being carried out between assertion consumer service and of SP and artifact resource solution service of IDP. And it will artifact response is being sent. So it's a valid one only. It will confirm, and then that once that is being done, resource is being granted. The user is being granted access. So this is about SAML request example. I said this is an XML. Okay, you can see this is an XML. You can see it's an authentication request. Okay, so the binding is a post binding and assertion consumer service URL. So likewise, there are details are there in this request. This is not going as a plain text bit. So this is kind of envelope of SSP sending to IDP while doing the redirection. Okay. This is based on SAML protocol. And This is in encrypted format. It is being sent in production usage. Okay. Same way, the SAML assertion is there. So it can have different things like this. So here it is a assertion. It is a assertion here. Okay, and here also you have the user is using email address name ID format. So email address is being of the user authenticated is being displayed. Okay, so and authentication methods. There are authentication statements are also there. Of course, you cannot see because it's optional. It's based on configurations only. It will keep on working. So this is the assertion snapshot example. Okay. Okay. So we have discussed on the SSO protocol so far. So that is used in single sign-on, and the SP and IDP do the uh, SP and IDP do the will trust each other, and so SP will trust IDP for granting user access to SP resources. So that's happening there. Now we'll come to authorization. So far we were telling about authentication systems and all. So now we'll come to authorization. So authorization, so see somebody, say when I work in a company, say there are 5,000 employees are there in the company. Okay. For each fight, so the IAM administrator will be there in the company. So IAM administrator cannot access permission to all these 5,000 users quite easily. So there will be groups will be created. So finance group, developers group, QA group, likewise, there will be different groups will be there. So each group has got a role in the company. So based on that, roles will be created. So if you belong to the role, if you belong to the finance group, you can see some contents which is protected by the company. And if you belong to the programmer group, developer group, you can see something else. Okay, I don't have to individually pick all the programmers and assign a role to them. I can add them to a group, and then to the group I can give a role. Okay. So that is about role-based access control. So if so, user group roles and are there. A bank manager. So think about a policy, RBAC policy. A bank manager can approve loans, but a loan officer can only review loan application. That's a RBAC policy. So what happens in the case? Bank manager role is approve loan. Okay, and loan officer role is review loan. So when this role is happening, so first in authentication, IAM systems and all, identity and access management. So authentication is to prove what you are capable of doing, what you are capable of doing. So that is authentication is happening. Sorry, what you are not capable of doing, what you are proving in the authentication, what you are. And in authorization code flow, what all you can see. Okay, I said I am George, I'm developer. Okay, so what all you are capable of doing, capable of seeing. So that is authorization. You are authorized for these all things. Okay. There is two parts to identity and access management. One is establishing identity, and once established the identity, the IAM system know your name now. Okay, you are George, and this is this person in IAM system. So it already know your roles. So it can control further your resources. Okay, because you established already the identity. Okay, so it knows the roles, configure the roles, and based on the roles only, you can see the resources. So that is role-based access control. And similarly, there is attribute-based access control. So think about allow users a attribute ABAC policy allow users from finance department to read confidential documents only during business hours, 8 and 6 p.m. Okay, so think about something like that, morning 8 to evening 6 p.m. So in that case, there are different attributes are there. One is department, which is finance. Okay, finance, and the attribute document type is confidential, and action attribute is read. You can read. Environment attribute is time of access, which is this. So if all these attributes are matching, uh, all these attributes can be set in case of ABAC attribute based control. So so that's a different kind of granting access. So these two often club together in case of establishing authorization policy, or in some companies only RBAC is being used. Some will club these two together to establish fine-tuned access policies. Okay. So this is something about multi-factor authentications. You already know this. I don't have to explain this. I hope multi-factor authentication means of course the username password login is not sufficient for secure access. If you want to access your bank details, just username password may not be sufficient. You may get an OTP in your SMS in your mobile application or something similar. Okay, an uh, additional proof you have to give. Okay, so that is called multi-factor authentication. So although you proved that you said you are George and I have this password, that is not sufficient. So because you are accessing a secure data, so again you have to give another challenge you have to answer. So that additional challenge can be one or can be more than one. Okay, two or more. Okay, so that is called multi-factor authentication. So in that, something example password, something you have smartphone. So you get an SMS in your smartphone. And sorry, you get an OTP in your smartphone. Okay, as an SMS message. Something you got biometric scan. All these are being used, okay, to establish this multi-factor authentication. So we have come to the theory part of the uh, identity and access management. There are many more things to identity management. Hopefully, I will cover in another video some more things on identity management. So as promised, I have to give a brief on Keycloak. Okay, so I don't go in deep on this here, but just give a brief on Keycloak here. So Keycloak is an IAM software which is open source. It is from RHEL. Okay, so you can see the source code of that. You can download the source code of that. So it's open source, and it's widely used in industry. Okay, so there are other authentication systems are there. IAM systems are there, which are from companies like Okta and different company identity and all. Okay, so this Keycloak is one of them, which is open source. And here, so we have discussed various concepts so far. So let's look at what is offered inside Keycloak. Okay. So first, let's look at this clients. Okay, so this is about so far we have said that so when I was discussing identity provider, I was actually telling Microsoft Azure Active Directory. Okay, but suddenly you assume okay, now you assume your identity provider is Keycloak. Okay, instead of Azure Active Directory, you assume your identity provider is Keycloak. Okay, so first, if you want to have, say, service provider connected to your identity provider, they have to register first. So they have to choose a protocol. So either SAML or OpenID Connect or OAuth2. Okay, so they have to choose a protocol and they have to select the grant types and all. They have to register. Okay, then the laying party and the service provider can communicate with each other. So that is about this clients. Okay, and so what is this user federation? So when I was starting, I said your company may have the users stored in Azure Active Directory. The HR may be maintaining data there, or suppose initially maybe in Active Directory. Okay, so which is a kind of LDAP server. Okay, so assume there is user data is being stored in Active Directory. Okay, now Keycloak actually comes with an it supports only RDBMS database. It comes by default with H2 database for development purpose, for easily setting up. But for production usage, something like Postgres or MySQL we have to use. And so Keycloak supports RDBMS database by default. But the user data is somewhere else. It's an Active Directory. Okay, so once a company adopts this Keycloak, okay, the whatever be the user data in the Active Directory has to sync to the Keycloak. So um, that process uh, is called user federation. Okay, so syncing the Active Directory information or LDAP information, it supports various LDAPs. So I just took Active Directory. So it can sync the user data in the Active Directory to the Keycloak database. So then in the case of authentication at IDP, so your IDP is Keycloak. So what happens? Keycloak will look its database because it's the users are being synced there. So it will identify your users, Active Directory users, because it's being synced there. Okay. And but for password, it will look back at the Active Directory itself. So that is called user federation. So some company want to configure Keycloak, so they don't have to manually create in the Keycloak database all these users. There is an automatic way of syncing from your Azure Active Directory. And Keycloak supports service provider interface. If something is not available by default, you can extend that by writing program. Okay. And roles, groups, users, and all we discuss. UA themes is to give and suppose you want to give a different look for your login window and all, then your UA themes will come. Similarly, events, you want to have suppose you want to have different logging events like user failed to log in, like this, for tracing the auditing purpose, you want to store information, then events is useful. And identity provider. Okay, so far I said Keycloak acts as an identity provider. Now you think the reverse way. Keycloak acts as a service provider. Okay, then the identity provider can be something else. Okay, Azure Active Directory or social login things like Gmail, GitHub, or anything like that can be your IDP, and Keycloak can act as an ID as SP. So that all configurable. So the Keycloak supports that. And one more thing you have to know in Keycloak is that there are different realms there you can create. So there is a master realm which is normally for administration purpose. Okay, so if your company has got different subsidiaries, you can have different REMs created for that, which will each have separate user data will be stored in each of the REMs. Okay, I have George in one REM, abc.com. That is sorry, I have REM is I have say somebody, some user George in one of the REM, then a different REM in the same Keycloak uh, may have may have a similar user George, but they are not identical in the database. They will be two different people as far as the REMs are concerned, because it's separated. There's no relations between REMs. Okay, so that is briefly about Keycloak. So this is what I wanted to cover, and there is something called client adapter. This is to help you write laying parties. Okay, so yeah, there are so it is a lot of programming to write a relaying party, but there are libraries for JavaScript. Spring Boots are there to write a relaying party. You can plug in your React.js application or Spring Boot and make relaying parties easier to communicate with the Keycloak. So that is called client adapters. So thank you for listening to this video, and hopefully I will come up with more videos on this. And this is mainly on theoretical part. I'll come up with the practical side also. Thank you for listening to this.